I am here with Avi Loeb. Avi, thanks for joining me.
Thanks for having me. It's a great pleasure.
Avi, a few weeks ago, you gave a TED talk about the search for alien life. And at the end of your talk, Chris Anderson came up on stage and stood beside you. And he asked you a very simple yes or no question. If you think within the next 10 years we'll have discovered truly convincing evidence that extraterrestrial life exists, and with very little hesitation, you said yes. Why this answer?
The reason is simple. We haven't really dedicated the major effort to search in the right way. I mean, we were waiting for radio signals for 70 years, starting with Frank Drake's OSMA project. And that followed on Cocconi and Morrison's paper in Nature that suggested that since we are using radio communication, perhaps we should listen to others. And that was very human-centric point of view, in the sense that it was, last century, 70 years ago, when we just started communicating with radio waves. Now we are doing much better with other technologies. And moreover, it's a very passive approach where you say, let me just wait for someone to call me. And we all know that that's not a good method to find a partner, because nobody may realize that we are lonely, or they may be hooked to their digital screens and not search for us. And we better be proactive. And there is another way, which is looking for any objects in our backyard that accumulated over time, space trash. The trash is our treasure. And this is an approach that was only pioneered over the past decade. The first interstellar objects from outside the solar system, were discovered only over the past 10 years, for a good reason. We just didn't have a survey telescope. Astronomers didn't use survey telescopes that are powerful enough to detect such objects. And the US government did not use an array of satellites that can look for meteors from interstellar space systematically. And so now we have those instruments. We know of at least three such interstellar objects, and it's a new frontier. Maybe among the rocks that we find from other stars, there would be some technological objects. And since I'm heavily engaged in searching for those, I'm optimistic that it's a road that was not taken. And when you take a new road, there is a chance of finding low-hanging fruit because nobody picked it up. And that's why I'm optimistic. I should also mention sort of a background anecdote here, because when they invited me to give the TED talk, they kept telling me every few weeks that I should practice. They said, practice, practice, practice. And I was very busy. I avoided any practice tests that they offered. And then I got there and they kept saying, you should practice and rehearse, and only then you'll be able to, because it's a very unusual experience being on stage with the lights on and so forth, and speaking in a way that approaches the entire audience. And so anyway, I did not listen to that. And then the night before, because of the time difference from Boston, Massachusetts, where I reside, I thought it's actually 4 a.m. and I usually jog at sunrise, but it was actually 1 a.m. And basically I didn't sleep that night because I went to bed at around 10 or 11 p.m. So I slept a few hours, but then since I was awake, I decided to write up my presentation. So I wrote an essay, as I usually post it on medium.com, and I had it fresh in my head. So I went on stage. Since I didn't sleep much, I was very relaxed. And I simply delivered my message straight from the heart. And the audience, laughed at all the jokes. There was standing ovations from the people in the room, in the auditorium, but also online. And by now it's out for about 10 days. The video of the presentation, it garnered 800,000 views already. So I think it was very well received. And perhaps my lesson is that instead of preparing for it like a show, one better prepare the content that would touch the minds and hearts of the audience. That's my lesson.
Yeah, fantastic. Oh, I mean, it certainly did. I enjoyed watching it, and many of the other interviews that you've done, and what you've written. And I will link to several of them. There was something very interesting about your answer, though, because so you answered yes, we will find evidence of advanced alien species, and it was all about the sort of the search, the fact that we need to search. But you almost presumed the answer that this exists. I think many people
Yes,
ask that question.
that's a very good point. Yeah. That's an excellent point. And obviously, it flatters our ego to think that we are unique and special. And over the history of science, we initially thought that we are at the center of the universe, and there is everything is built around us. And you can interpret that in two ways. One, that we are quite arrogant in the way we think about the world. It's all about us. Another approach is to say we are ignorant. So all the information we get is from our immediate environment. So therefore, we think that we are at the center. And the second interpretation is actually what explains the way my daughters behaved at a young age. They thought that they are at the center of the world. And that's because their experience was confined to home. And we paid a lot of attention to them. But on the first day at the kindergarten, they had a psychological shock. And they matured. And so my sense is that we will mature once we realize that we are not at the intellectual center of the universe. And because right now, if you ask people in academia, they would tell you that it's an extraordinary claim to suggest that we are that we have partners like us, intelligent out there, and it requires extraordinary evidence. I think it's the other way around. I think all evidence shows that we are not really at the pinnacle of creation, that in fact there is a lot of room for improvement if you just read the news every day. And we are engaged in conflicts, in destructive measures. We spend $2.4 trillion on military budgets instead of cooperating and working the way science advocates. It's an infinite sum game, and the more we know, the better our life would be in the future. And we know that from the past century of science and technology. And we don't learn the lesson. There are two wars right now about zero-sum games, territories that the two sides want to have. And if you just think about it, the Earth is a residue from the formation of the sun. It's a tiny piece of rock. And for us to just look down and ignore the vast real estate that is out there, it's really pretentious, and it's foolish. And there are hundreds of billions of stars like the sun in the Milky Way galaxy alone, and we now know that a fair fraction of them, maybe a quarter, have a planet the size of the Earth, roughly the same separation. So why should we think that we are unique? I think the default assumption should be that things like us should exist. Now, the argument is that, intelligence arose on Earth in the last bit of the Earth history, only in the last few million years, and primitive life, microbes, existed since the beginning. Recently, there was a paper dating Luca, the last universal common ancestor. If you trace back in time all biological life on Earth, including humans, whales, bacteria, everything, there is a common ancestor, and it was possible to date when it started. It's 4.2 billion years ago. Very close to the time when the Earth cooled to allow the chemistry of life as we know it in liquid water. And so that means that primitive life is probably very common because the Earth had it as soon as it cooled, and probably Mars had it even earlier because it cooled before the Earth. And perhaps life on Earth came from rocks that were brought to Earth from Mars, because that was a period where rocks were exchanged much more vigorously. There was a heavy bombardment at the time. So we might all be Martians. And if you think about Elon Musk wanting to go back to Mars, it's actually going back to our childhood home, potentially, if life started on Mars. But at any event, the point is that you might argue that intelligence is rare because it only appeared in the last bit of the history of Earth, one part in 10,000. But the thing to keep in mind is to find intelligent life or technological signatures might be much easier actually, because if I go to the Pacific Ocean and I find an interstellar object that is artificial in origin, think of it as Elon Musk's car, the Tesla Roadster car that was launched as a dummy payload to space in 2018. And I'm just saying maybe he is not the most accomplished space entrepreneur since the Big Bang 13.8 billion years ago. Maybe there are others that launch cars. And if one of them collides with Earth, an interstellar car, we might find the engine in the ocean. Or it might be something better than a car. It might be, a sophisticated gadget that just stopped functioning and then collided with Earth, space trash. And if I find that, it will be clear evidence that it's not human-made and it's artificial because it has buttons on it. The only questions would be whether we should press a button. And on the other hand, if you look for molecular signatures of bacteria or some primitive life forms on an exoplanet around another star, you might look for oxygen, methane, carbon dioxide, water molecules. But these could all be produced by geological or chemical processes that have nothing to do with life. Just to give an example, there was a paper in Nature recently that suggested that there are deep in the ocean, on the ocean floor, when there is not much sunlight, so photosynthesis is not possible, there seemed to be a mechanism for making oxygen that is based on electricity and a electric potential difference across the surface. And that is electrolysis, it's called. That's breaking water molecules to their constituent oxygen and hydrogen just by having an electric potential drop. And if nature can make oxygen this way without life, then if we find oxygen in the atmosphere of another planet, and by the way, it will cost us more than $10 billion to do that, to build an observatory looking for oxygen in a planet that transits the face of its host star. So my point is, even if we find it, it will not be conclusive. But if we find a technological signature, it will be conclusive. And moreover, even if one civilization across the entire galaxy produced a self-replicating probe, a probe that has a 3D printer and has artificial intelligence that goes places and reproduces itself, just like a dandelion seed. The flower sends seeds in the wind and they spread and recreate the flower from the DNA, from the genetic information that is in the seeds. So nature does it all the time. You can imagine a technological gadget that is self-reproducing. And if that is being launched even by one civilization at the edge of the Milky Way galaxy, within 1 billion years, it can make its way and fill up the entire Milky Way galaxy. So all I'm saying is it takes one such civilization to fill up the entire volume with those self-replicating probes very quickly. And I'm about to submit a paper on Monday, in a couple of days, that calculates, where will Voyager be billions of years from now? It turns out that within 2 billion years, Voyager will be on the other side of the galaxy compared to the sun. And then it will come back to the vicinity of the sun in 4 billion years, before the sun becomes a red giant, by the way, which will take 7.6 billion years. So at any event, all of this is to say that, most stars formed billions of years before the sun. There was the star formation history of the Milky Way was calibrated, measured, and there was a burst of star formation 10 billion years ago. Now, if you imagine a civilization like ours forming around a sun-like star that was made 10 billion years ago instead of 4.6 billion years ago, there was plenty of time for that civilization to send the chemical rockets that would arrive to the solar system, even if they were launched from the opposite side of the Milky Way disk. And so what that tells you is that there is a good chance that we might find some traces of other civilizations. And I call that space archaeology, basically looking for, or you can call it space astroarchaeology, looking for traces of civilizations that existed before us, just as we do here on Earth, except it's in space where time is measured in billions of years.
Mm. Yeah, I guess what you're touching on there are different ideas of kind of search strategies for looking for life out there, and I guess the selection of the most likely strategy depends a lot on the sort of background assumptions of what the nature of that life might be. And I'm interested to know if there is any sort of consensus view among astrophysicists today about what that might look like, and if not, what is driving the difference? So why would that? What is the difference in worldviews between astrophysicists, such that there could be such disagreement on how to search for life?
Well, first, let me say, if you go on a date here on Earth, then it's very likely that the person you meet will share a DNA that resembles yours. The person will have two eyes, two ears, but when you deal with an encounter with life from another star, all bets are off, because it could be life as we don't know it. Even within the solar system, on Titan, the only other object other than the Earth that has liquids on its surface, it's a third of the surface temperature of the Earth relative to absolute zero, 90 degrees, and it has liquid methane and ethane. And really, my desire, my wish is to go fishing on Titan. It's a moon of Saturn. Why do I want to go fishing? If I catch a fish, I will not eat it for sure. It's a health hazard. Something that swims in methane and ethane is not good for your health. But it would show us that life as we don't know it could exist, and it could be something really weird. And I would argue the same about intelligence. Intelligence may not be unique and understandable for us. People often argue that mathematics and science speak a language that is universal, but I would not be that confident. And therefore, I think it would be really difficult for us to anticipate what we might find. My approach in terms of looking for objects is basically to be open-minded, not to assume anything, and just look for something that is not familiar. Okay, so if we find objects in the sky that are not human-made and are not natural, and they look technological, then I just want to know what they look like, because I don't want to assume anything. I just want to find something not familiar to me. Okay, so that's the approach I take without assuming anything. Now, with respect to the search that most of the astronomy community takes, it's a search for biosignatures or molecular fingerprints that may be indicative of life, primitive life, on exoplanets, in the atmospheres of exoplanets that transit the face of their star, so that we can see the absorption fingerprints of various molecules in the atmospheres of those planets. And that is the definition of the next big observatory, the Habitable World Observatory, that is currently the favorite. It was recommended in the decadal survey of astronomy and astrophysics issued by the National Academies in the US. And such an observatory right now is estimated to cost, by NASA, to cost about $11 billion. My point is, before we invest $11 billion in looking for oxygen, where, as I said before, might not necessarily imply life, we should invest tens of millions of dollars to study interstellar objects. That was not done. And this is such a small fraction of the cost that it's worth doing first, because perhaps this approach of looking for objects among all the interstellar rocks, there might be some space trash. And the reason I'm saying that is because out of the 3 objects that we identified over the past decade, there were the interstellar meteor IM-1 from 2014, Oumuamua, much bigger object, about 100 meters in size, that was not a meteor, did not collide with Earth, but was noticed based on the reflection of sunlight from it in 2017. And then the third one was a comet called Borisov in 2019. Out of these 3, the only one that is familiar is Borisov. It's just a comet. But the meteor was of unusual material strength because it disintegrated only in the lower atmosphere, where the stress was higher than on any other meteorite. So the stress exerted by the friction on air was unprecedented before the object disintegrated, which suggests that it may have had an unusual material strength. And it also was faster than 95% of the stars in the vicinity of the sun. So that's IM-1 from 2014. And then Oumuamua had a weird shape. The amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And it was also pushed away from the sun by some mysterious force without any cometary evaporation. So there was no rocket effect acting on it. And finally, Borisov indeed looked like a comet that is familiar. And so my colleagues made 2 statements. One of them, who is an expert on solar system objects, after there was a colloquium at Harvard, at the Institute for Theory and Computation, for which I serve as director, it was about Oumuamua around 2018. And when we left the room, my colleague said, Oumuamua is so weird, I wish it never existed. And, to me, that's the wrong attitude. If you are really driven by curiosity, you really should be excited when something doesn't fit your past narrative, because nature is trying to teach you something new, and so the other thing is, obviously there were many papers written about Oumuamua trying to explain it as a rock of a type that we've never seen before. And I said, well, maybe it's pushed by reflecting sunlight, in which case it would be very thin, and that's something that nature doesn't make. And maybe a surface layer of an object, a broken piece of a Dyson sphere. And so I think until we have more data, we can't really tell. And of course, the lesson from that is, let's find more of the same. And in a year, there will be a new telescope in Chile called the Rubin Observatory that could potentially discover an Oumuamua-like object, every few months. And I'm really eager to get more data on any object that looks as unusual as Oumuamua was. And then when Borisov showed up, people said, well, this one looks natural. And I said, of course. And they said, well, doesn't it convince you that Oumuamua is natural? And my answer was that, if you go down the street and you see a weird person, and after that you see a normal person, it doesn't make the weird person normal.
Yeah, it's really fascinating. I want to dig into the hypotheses around these mysterious interstellar objects, and what it is about them that makes us think that they might be technological. I guess one of the key background things that needs to be true in order to take one of these hypotheses seriously is some sort of background belief on how likely it is that such technology would exist and would come into our solar system, for example. And there seems to be a fairly stark divide here in views, because reading the history of Oumuamua, for example, the things you've written, things that have been written about your papers, I would say it's nothing short of vitriol, actually. There is some very stark disagreement. And I find that very, very curious, because we all do come to this question with basically the same information. Astrophysics community has the same information about how interstellar objects work. And yet the conclusions that are drawn do tend to differ quite starkly, or the openness to these strange hypotheses do tend to
Right.
differ quite starkly. What's at
Well,
the heart of this?
well, if we had conclusive data, if we had good enough data, we could tell if it's an unusual. Like, to give you an example, some of the mainstream scientists advocated, oh, it's a rock made of pure hydrogen. We've never seen an object made of pure hydrogen. Why should that be the mainstream view? Why? Just because they don't want to consider the possibility of a technological object. Okay, that's the only reason, because we have never seen, we don't know if hydrogen icebergs are made in the first place. So I said, okay, forget about it. Let's assume that they are made. They would not survive the journey. So I wrote a paper with a colleague, Tim Huang, where we show that an iceberg made of hydrogen would not survive the journey. And the authors of that suggestion said, yes, right. Okay, so maybe it was a water iceberg that was turned into a hydrogen outer layer, and then we showed they made a mistake in the energy equation, and they did not respond to that. At first, they said our papers need to be refereed before they respond to that. And then when our paper was published, they didn't respond to that. And the strange thing is also that reporters reported about their paper, but when we show that it's wrong, they did not report about that. And I asked the editors of Scientific American, and they said, we don't want to confuse our readers. Now I ask you, is it more confusing to report the truth than if you don't want to confuse the readers with details about why an argument may be wrong, then how can you get credibility as a science journalist? You need to present all the information we have. So if they made a mistake in the energy equation, they should either address it. And by the way, the mistake is a factor of 1,000,000. I'm not talking about factor of order unity. And then there was a suggestion, oh no, it's actually a nitrogen iceberg, chipped off of a planet like Pluto. And we wrote a paper showing that there is not enough solid nitrogen in the Milky Way galaxy to make a large enough population of those. So, of course, you can insist that you are representing the mainstream and talk about objects that do not exist. But why should that be more credible than a possibility that is not ruled out, that it's technological in origin, simply because it's so weird? It's not that I was dreaming of a technological object out of no evidence. There is evidence that this object is different than the rocks that we are familiar with. Okay? So to me, it sounds like common sense that this possibility should be entertained. But what happens in academia very often is that because the stakes are low, unlike in politics, where it's life and death situations sometimes, because the stakes are low, you can have mobs that do not follow common sense. They will just insist, because they were experts on rocks, that it's a rock of a type that we've never seen before. And I say the same will happen if the Tesla Roadster car would collide with Earth, and appear as a meteor. They would say it's a red rock of a type that we've never seen before. So at which point would you say, okay, well, these people are not reasonable? Once you have material evidence or very clear data that indicates that they're wrong, and that takes time and effort. Now, many of those have opinions. People have strong opinions. I don't mind that they have strong opinions, but they should not ridicule the alternative if it's just a matter of opinion. And they do ridicule that alternative. But you look at the history of science, and you see that many of the truths that are held very dearly as such were ridiculed. And that includes dark matter. There were people very strongly opposing it and claiming that that's ridiculous to consider that there is matter other than the one we know in the universe, that it makes 85% of the matter content of the universe. The idea of plate tectonics came from a very long history. It took 40 years before the scientific community accepted the idea that the Africa was connected to, Australia and to the Americas. We could have had an in-person conversation, in the same room. I could have driven to your place if we lived 250 million years ago, because New Zealand, Australia were all part of Africa. And when that was proposed by Alfred Wegener in 1910, it was argued that he is not an expert, he doesn't know what he's talking about, and that's ridiculous. And he died in the 1930s, with the entire scientific community ridiculing his idea, until 20 years later, it was realized that the vegetation in Africa and South America match along the shorelines, that the geological record indicates they were all part of the same supercontinent. Okay, and there are many such examples. Even meteors, people thought that before 1803 that rocks cannot fall from the sky. I mean, we see rocks around us. How can a rock fall from the sky? That's ridiculous. Until there was a meteor shower in Liège, France, that a lot of people saw, and then it became the consensus. And now what you find is people arguing that rocks can only come from the solar system, or at least there is no evidence for interstellar objects colliding with Earth, which is, we can talk about it because I went on an expedition a year ago to the Pacific Ocean to look for the materials from a meteor for which the data was obtained by US government satellites from the light generated by the fireball of this meteor. And they measured the speed of it, and it was definitely unbound to the sun, and moreover was moving faster than most stars in the vicinity of the sun. So at any event, these situations happen over and over again. And my point is, let's be open-minded, and let's approach the universe with the curiosity of a kid, rather than pretending that we know the answers in advance. And what that means is that you need to engage in the hard work of collecting evidence. And it's a lot of work. It requires money and it requires time. But it's much easier to sit on your chair and say, I'm an expert on the subject, and how dare someone else say something that violates what we already know, and I know what I'm talking about, and then ridicule the person and say bad things about the person, not about the substance. That is bad practice. That is not science. And then there is another group of people that was not there, 50 years ago, but now is very vocal. And that's people that blog on social media. There are some science journalists, and some of them claim that they are astrophysicists. They're scientists, but you check their CV, their resume, and they haven't published a single scientific paper over the past decade. So then you ask yourself, how is it possible that, a book critic that never wrote a book over the past decade would claim to protect the profession of writing books and argue against writers who actually write books right now? So I'm actually doing science, it's a lot of work, and I get critics that do nothing, and they just appear to make comments in the media. And the visibility that they get is because of my hard work. But they go negative about it, but without doing anything. And it's just bad practice. And I regard those activities as anti-science, because science is supposed to be guided by evidence, and evidence does not fall into our lap. New knowledge does not fall into our lap. We had to invest $10 billion in the Large Hadron Collider to discover the Higgs boson. We had to invest $10 billion in the Webb telescope to find the first galaxies. My expedition cost $1.5 million. The next one will be $6.5 million. It's really a lot of work to coordinate an ocean expedition and collect materials from a depth of 1.5 to 2 kilometers across a region that is 11 kilometers in size, which is what we did. And after we put all this effort and brought back material, it took us 9 months to analyze it. But it didn't prevent people who didn't do anything, who didn't have access to the materials, to make statements, express opinions. So, I think if you are guided by evidence, you should be always excited that we are finding something that perhaps represents new knowledge, because that's the whole purpose of science. And let's be guided by evidence rather than by opinions.
I mean, all of this really draws up the question of the function of our scientific institutions more generally, and their ability to deal with highly speculative topics. And as you
Well,
mentioned,
it's not that, because if you look at other areas, let me give you two examples. One is dark matter. For 50 years, there were searches for dark matter. And you might say, oh, well, that's mainstream, of course. We know that there is dark matter. Yeah, but what is the nature of dark matter? So the popular view was that it's weakly interacting massive particles, and perhaps they represent a new symmetry of nature, supersymmetry. We invested billions of dollars looking for weakly interacting massive particles in laboratory experiments. Most recently, in the Large Hadron Collider, we were looking for supersymmetry. We haven't found it. So you say, well, was that a speculation? It's not defined as a speculation because the mainstream adopted it. We spent billions of dollars, we didn't find it. So in retrospect, was it a speculation? Of course, because it wasn't found. How can something not be found if it's not a speculation, right? So in retrospect, it was a speculation. So then you need to ask, why was it embraced by the mainstream, this particular speculation? Because people thought it makes sense, because of its mathematical features, because things sort of came together in some way, but it didn't end up describing reality, which is really the goal of physics. Okay? So whether you choose the option of dark matter being weakly interacting massive particles that are representing supersymmetry or not is a matter of taste. So then you have to ask, is this more speculative to consider the possibility that interstellar objects which look anomalous might be technological? Is it more heretic and controversial than considering the dark matter to be of something that it's not? And it's not just this option, it's the option of axions, it's the option of there are lots of examples, there are lots of wrong ideas in the context of the search for dark matter. We still don't know, after 50 years of doing experimental work, we still don't know what it is. Okay. And think about even a worse example than that. Consider string theory. That's an approach to unifying quantum mechanics and gravity. It's mathematical gymnastics because it was never demonstrated by any experimental data to be the correct approach. In fact, it doesn't even make a prediction that is unique. There are many possibilities. And within our lifetime, there is no experiment that anyone conceived that would test the ideas of string theory. Or let's put it this way, one experiment was looking for supersymmetry, which some people regarded as the foundation for string theory. It was not found. So the answer is, oh, well, let's just wait. Maybe the next experiment will find it. But it was not found. And then extra dimensions is another facet of string theory. We don't have any clue that extra dimensions exist. But yet it is the mainstream for 50 years of theoretical particle physics. And the brightest minds are working on it. And they don't have any, they don't feel that they're speculating because everyone is doing it. And they give each other awards and honors. And it's considered the mainstream. And anyone that makes calculations in the context of string theory uses it as a sandbox for doing mathematical gymnastics to demonstrate that they're smart. Okay, so that it serves an important purpose, but is really the purpose of physics to demonstrate that we are smart or to find out what nature is? And it doesn't require much mathematical sophistication to look at an object and say it's technological in origin and it's not human made. I don't need extra dimensions for that. But that would be regarded as an extraordinary claim, whereas the fact that we live in extra dimensions, sure, be my guest. And then you think about it, that's for 50 years, mainstream. And I had breakfast with a string theorist, and I asked him, "What's your most important scientific paper?" And he said, "It's a paper about supersymmetry." And that's one of the leaders of string theory. And I said, "Well, but it was not found by the Large Hadron Collider. So how can you regard it as your most important paper? After all, physics is about describing reality." And he said, "Well, we just have to wait. The next accelerator might find it." And that reminded me of the religious Orthodox community in Crown Heights, New York City, where it's the Jewish community, and I'm Jewish, but so I can mention that. Then they believe that their rabbi will become the Messiah after he dies. And the rabbi died and didn't come back as the Messiah. So that was a data point. Just like we didn't find supersymmetry. So what did the community say in response to this data point? They said, we just have to wait. Now, that is understandable in the realm of religion, faith, but is it very different from a string theorist just saying, let's just wait another 100 years, another 200 years, another millennium? Maybe then we'll have some evidence. So when you ask me about mainstream in academia, it's not, it doesn't resist speculation. That's not true. I just gave you an example of a theory that not only speculates, but there is no, in the horizon of our lifespan, there is no experiment that would test it. And they don't need it to be proud of the work they're doing. So if that exists, why aren't we embracing the search for things like us on planets that look like the Earth? I mean, to me, it sounds like common sense, doesn't it?
Yeah, I guess you do face the chicken and egg problem, though, of needing to invest a lot of time and a lot of money and a lot of effort into accumulating the evidence that supports these hypotheses, but then also needing to have some conviction that you're going to find something useful before investing that time and energy and effort.
Well, but why would you invest 50 years in searching for extra dimensions?
Oh, I think the string the string theory question, I think, it's a whole different kettle of fish. But
well, it's not just string theory. Why weakly interacting massive particles as the dark matter? There are other people who work on primordial black holes as the dark matter. People make speculations and then stick with them for decades, but they would not argue that it's not worthwhile, whereas in the context of searching for things like us, they would argue that it's controversial. And just the search for the evidence. I'm not talking about the idea by itself. Now, why would that happen? I mean, the public clearly has a different view, because the public, there are more people who believe that we are not alone, that there is an intelligent species out there, than the number of people who believe in the biblical God. And very often, committees that allocates funds for science argue we shouldn't take on a risky project because we might be wasting taxpayers' money. And I say, did you ever ask the taxpayers what they want their money to be spent on? Because if you did, they will tell you that they're much more curious about whether we have a partner in interstellar space than the question of what the dark matter is made of.
yeah, it's interesting because I think there has been a shift in the public perception and understanding, or just I would just say the base assumption of what is out there in the universe. I mean, even in the last 20 years, there has been a stark shift where I think the default assumption now is that we are almost certainly not alone. But yet there is this dissonance, because I think that belief is true and that belief is also held by scientists. But then there is also a very stark resistance to an extraterrestrial hypothesis that explains anything that we do see. And to me, those two views do seem very much in tension.
Well, the situation is that you have critics or skeptics and believers, and they polarize the discussion. just the way it's in politics. You see the far left and the far right making unreasonable statements and helping each other to survive. So the extremes actually dominate the scene. And so what happens is you have within the public people who know the answer. They don't need the scientific evidence, but they know that we are visited. Some claim that they were abducted, and all kinds of ridiculous claims. And then, of course, the scientists say, we don't want to sleep in the same bed as those people. So we don't want to work on this subject. But I say that's not the right approach, because 1,000 years ago, there were people claiming that the human body has a soul and that it should not be dissected because you can hurt the soul of a person if you open the body. And imagine if scientists were to attend to this notion, they would never develop modern medicine the way it is now, that saved lives of many people. So what is the lesson to be learned? That we should not abide by how ridiculous some of the ideas are on the subject that we are studying. We should study it by collecting new evidence that will guide us for the answer. And that has been true throughout science. That's what we should do. And if there are people making, crazy statements on either side, they should be simply ignored. Because going in the middle of the road, is the most commonsensical thing to do. Follow the evidence, but it's the least populated path. So when people say artificial intelligence will help science innovate, I say you have to be careful about that, because you train AI systems like the large language models on what people do. And most people are taking extreme views or making statements based on opinion, not based on evidence. So if you train AI systems on the way people operate, and that includes in academia and in science, you will never take the middle ground, which is the most sensible thing to do, because it's the least populated. Most of the time you have an opinion. People have an opinion. A biological brain is driven by jealousy, or doesn't want anything new to be said about the field of an expert. It's driven by competition for limited resources, and it's driven by tribalism. If there is a group of people that you can relate to and all of them say the same thing, you feel stronger, and you just want to cancel the people in the other tribe. And so all of these motivations end up being very toxic and destructive for the progress of scientific knowledge. And I find that to be unfortunate, because basically you lock the mainstream in a direction that may end up not being the most productive one. You should let many flowers bloom.
But isn't the issue that we're talking about here with sort of scientific consensus and where the community focuses almost the opposite of what you said about extreme views proliferating? So, for example, you mentioned if we were to leverage large language models to help scientific progress, it's going to be trained on extreme views. But at the same time, we've said that there is sort of like this inertia in the scientific community to stick with what's known. Are these two views in tension? Isn't the issue that we're talking about
No.
a lack of openness?
So what I mean by extreme views is that people stick to what we already know and have extreme views on new knowledge, on innovation. They basically step on any flower that rises above the grass level. They don't want something new. Like if there is an expert on meteors, that expert would prefer to assume that every object coming from the sky is a rock from the solar system, and that you need extraordinary evidence to demonstrate something else. Just the way that before 1803, no rock could have come from the sky. So the idea is that by extreme views, I mean basically resisting evidence that violates past knowledge. That's an extreme view, in my opinion. If you have evidence that implies something different than what you were expecting, it's an opportunity to learn. Now, of course, you could have false alarms. You could have, and the only way to find out that it's a false alarm is by collecting more evidence. So you should be thrilled if something completely unexpected comes your way, and then you should be motivated to look for more evidence in order to firm up the conclusion. And if it ends up being nothing, if Oumuamua ends up being an object from a new class of, hydrogen icebergs, so be it. We learn something new. But you should not assume that what you knew in the past must be the case. And that's really the way that, based on my experience in science for many decades, it's the most common response that you get to a new idea. Now, the other thing is I worked in cosmology, studying the universe where the dark matter is not known. And within that intellectual culture, it was encouraged to come up with ideas that are not conventional because, we just don't know what the dark matter is. So maybe experimentalists can rule out this or that possibility. It gives work for people to rule out possibilities if you come up with those suggestions. And so when I saw the data on Oumuamua, it intrigued me, and I came up with the possibility that maybe it's artificial. And I didn't see anything bad about it. And the paper was accepted for publication within 3 days. But the minute that the media paid attention to this idea, and this was a paper, the only paper I know from the Astrophysical Journal that was quoted verbatim on CNN by Michael Smerconish. The minute that there was a lot of attention to this possibility that this object was weird and possibly technological, my colleagues started pushing back, and the more attention the subject got, the more personal they got. And so to me, that indicates very clearly that it has nothing to do with the evidence and nothing to do with being open-minded. It's just jealousy for the attention.
Yeah, I would like to explore that that sort of like personal stage of your career shortly, but maybe just to make it really practical for a second. We've talked about evidence for technologically advanced civilizations, and we opened with that question from Chris Anderson. Maybe let's just make it very practical. What specifically would you be expecting to find in the next 10 years? And what do you think we might be able to find that would actually convince a large portion of the scientific community that this is an idea worth taking seriously?
Yeah, it's very simple. Just consider the Rubin Observatory in Chile, funded by the National Science Foundation, that will start operation in 2025. It will employ a 3.2 billion pixel camera. And by the way, the secondary mirror of that telescope was just put in place. 3.2 billion pixels is 1,000 times more than you have on your cell phone camera. And it will survey the southern sky every 4 days. So based on my calculations, it should discover if Oumuamua was one object from a population on random trajectories, if it was not intentionally visiting in a very specific orbit, the vicinity of Earth, but there are plenty such objects and they just move on random trajectories. Then the Rubin Observatory should find one every few months. And that means that we will have plenty, within the coming years. And then we can check if all of them are rocks, or maybe, if there are extremely unusual objects, we can get more data because now we have the Webb telescope that could detect the infrared emission from such an object. We didn't have that when Oumuamua showed up. So we can actually measure the emission, the thermal emission, the heat coming from the object, not just the reflection of sunlight. And that, given the distance of the object, can tell us the size of the object. We can also pinpoint very precisely by triangulating the location of the object using a telescope on Earth and the Webb telescope that is 1.5 million kilometers away from Earth. So it's called parallax. You basically have two eyes looking at the object. You can figure out its location extremely precisely. And so if we get a lot of data on the next Oumuamua or the next weird object, and we realize it doesn't look like a rock, looks like a piece of metal made of, if we learn about the composition, doesn't look like a rock, I think it will be difficult to ignore that and argue that it's a rock. It's a piece of metal that was produced in molecular cloud, the way that the hydrogen iceberg idea was invented.
Like a Boltzmann brain just
And
emerging from the dust.
So that's just an example. And of course, if something collides with Earth, like this meteor, there is a chance that we would find the relics of what is left over from the wreckage. And then it's easy to tell if it's human-made or technological from another civilization. And these are examples where, and also even if you look at something in the sky, and I'm leading the Galileo project, and we have one functioning observatory. So this is an observatory looking at the sky all the time in the infrared, optical, radio, audio, now also ultraviolet, and we're analyzing the data with machine learning software and just looking for objects that are not familiar. And so far, over the past 6 months, we saw more than 500,000 objects, and all of them looked familiar. The only reason we built this observatory is because 3 years ago, the Director of National Intelligence in the US, Avril Haines, submitted a report to the US Congress talking about unidentified anomalous phenomena, objects that the intelligence agencies cannot identify, which means two things. Either they're not doing their job, and these are, objects produced by adversarial nations to spy over the US, and or they are extraterrestrial. So obviously there is a lot of crap in the sky that humans make, balloons, drones, airplanes. So we want to see if there is anything else. And since then, of course, the Director of National Intelligence submitted 2 additional reports, and there was a new office established in the Pentagon to look into those reports. But instead of waiting for the government to tell us what lies outside the solar system, that's not their day job. Their day job is national security. And my day job is to figure out as an astronomer what lies outside the solar system. So the sky is not classified, and we are looking at it. And we are now writing a number of papers talking about the preliminary results and the fact that we haven't seen anything. So once again, you have these communities of believers and skeptics. And I get attacked from both directions by taking the most sensible thing, the most sensible approach, which is to build an observatory and collect the evidence, collect the data, and whatever we find, we'll report. And that was not done before in a systematic way like that. And to me, again, it's common sense. But somehow common sense is not common in academia.
Yeah, I mean, suppose we were to go ahead and build this observatory, and for many, many years, all we did observe was rocks. It was all rocks, and there was no evidence of technology. What would you make of that? Like, at what point does the burden of proof start to sway the view towards, perhaps there is no technologically advanced civilization out there? What would it take?
Yeah, I think if within the coming decade, let's say we invest tens of millions of dollars, which is not, there are people, wealthy individuals, who are approaching me routinely, and are supporting the research. And so suppose we do invest tens of millions of dollars, which, again, to remind you, it's much less than $11 billion in the world, in the habitable world observatory that the mainstream wants to invest in. And suppose we do it for a decade and we don't find anything, that to me would be a strong argument that maybe indeed we can basically put an upper limit on the fraction of objects, interstellar objects, that are technological. Okay. And I asked this question a person who gave a talk at a conference that I organized a decade ago about dark matter, and the person was speaking about weakly interacting massive particles. And I said, look, you've been searching for decades for weakly interacting massive particles. You haven't found any. How long will you continue? You did it for decades. You're now in your late 50s. You have a couple of decades left. How long will you continue? And he said, oh, the decision is really simple, as long as I get funded. Now, the thing about it is he continued to be funded because that's part of the mainstream. But the way I see it is, it's not a question of money. It's more a question of the fact that we live for a finite amount of time, and, we better make the most out of it. Okay. So to me, this is such a fundamental question that I want to spend a decade checking. But if I don't find anything, I might decide to move on to something else. Just the way I worked on the first stars and galaxies, for the first decade of my academic career, and I pioneered this subject that is now, the main focus of the Webb telescope, and it was celebrated at the White House, and looking for the first stars and galaxies. That's a subject that I pioneered early on in my career. And in the same way, I worked on black holes and suggested imaging them, and now it's a big industry of imaging black holes. And I was the founding director of the Black Hole Initiative at Harvard University, where the first image of a black hole was obtained. So I worked on subjects of over a decade that ended up, producing important science. And if this one does not, so be it. But until I spend that decade, I'm not convinced. So if I find something, this would be the most important accomplishment, not only of my career, but of science in general, because it would have huge implications for the future of humanity as to whether I call it the most romantic question in science. Are we alone?
Yeah. Do you feel we're ready? Do you feel we're ready to? I mean, maybe we will never be ready. But to.
Oh, I don't care if we're ready. The point is, we were not ready to be orbiting the sun, and the sun orbiting the center of the Milky Way, and the Milky Way moving in some random directions relative to the universe at large. We were not ready for that. We thought everything moves around the Earth. But who cares? Now, of course, Nicolaus Copernicus cared. You can see his book behind me on my left side, because I was invited by the Polish government just half a year ago to deliver a keynote lecture in celebration of 550 years to the birth of Nicolaus Copernicus. And my lecture was about the next Copernican revolution, meaning that we are not at the intellectual center of the universe. And Copernicus did not want to rock the boat. By the way, he was a priest. So he wanted to help the church. And the church had a problem. They couldn't get Easter correctly. They always got it off by a few days. And they used the model in which the Earth was at the center. So Copernicus realized that if you put the sun at the center, he can get Easter predicted much more precisely. And gave the model to the church. And the church said, thank you very much, we will use your model. But we all know that in reality, this is just a theoretical model. In reality, the Earth is at the center. And they banned his book. It was a forbidden book until the 19th century. And on his deathbed, he was presented with the first hard copy of the book. And, he didn't want to rock the boat. 50 years later, Galileo Galilei rocked the boat. He was put in house arrest. And I really connect to Galileo much more than to Copernicus. I actually gave a lecture called Cattedra Galileana in Scuola Normale Superiore in Pisa, where Galileo was. The reason I connect to Galileo more is because, if the boat is heading in the wrong direction, we need to rock it.
Do you suppose you rocked the boat and we did discover conclusively sort of extraterrestrial technology? How do you think the world would react? What would change? Because like part of me thinks there is such a strong belief there, as we've said, that extraterrestrial life does exist. And if that's true, almost finding it shouldn't actually change that much because the belief is already there. What is your vision for how the world might change?
It really depends on what we find, because there is a chance we would realize that the object that we found represents technologies of the future. Simply because that civilization had more than 1 century of science and technology. We discovered quantum mechanics only a century ago. I'm 61 years old. I actually lived through more than half of modern science. Can you believe that? Since the time I was born in 1962, so I'm actually 62 years old. I lived half of the history of modern physics, including relativity, quantum mechanics, everything we use now for gadgets, building gadgets. Now imagine another civilization that existed for 1,000 years of technology, or 1,000,000 years of science and technology, or maybe even 1 billion years. They would produce things that represent our future, but we can't really imagine. And we would have some religious awe looking at those things. There is the biblical story of Moses in the Old Testament, looking at the burning bush that was never consumed. And that convinced Moses that there is a superhuman entity that he called God. Nowadays, you can buy online gadgets that would have been much more impressive than a burning bush that is not consumed. And if Moses were to see them, he would be filled with the same religious awe. Now, it would be towards us, but we just represent a more advanced technological civilization relative to Moses. That's all. So my point is, it will affect our religion. Just think about another civilization capable of actually solving the puzzle of how to unify quantum mechanics and gravity. So they would have a good idea about what happened before the Big Bang. And they might even have a recipe for how to create a baby universe, because if you know how our universe started, you might try to create it in the laboratory. And that's the job description of God. If you were to advertise the job description of God, such a civilization could apply for it. Because if they are able to make a universe, what else? They can make everything else that is in it, including life and everything. So my point is, if we meet a higher level of a technological civilization that might look like it does miracles for us, it might bring science and religion together for us. That's a huge impact on the history of humanity. And then the other thing that can happen is, there is the Darwinian principle of the fittest surviving. And you think about it long term, not just over time scale of years, thousands of years, or millions of years, but billions of years. Okay, so what does it mean to be the fittest? Well, in 1 billion years, the sun will boil off all the oceans on Earth. We will not be able to stay on Earth. All life as we know it will be eliminated at that point. And you can imagine a mass exodus of humans, and other planets like the Earth must have gone through that, because their star formed billions of years before the sun. And so in that case, just knowing what happened to other civilizations, learning from their history, figuring out how they managed to survive, it could be inspiring for us, and we might behave differently. And at the very elementary level, if we realize there is someone else out there, it might unify us because we would feel that we are all on the same boat, the earth. We are all part of the same team. We will stop killing each other because we depend on each other for the future. And perhaps we will explore space the way they did. And perhaps we will change our priorities. This shock therapy is the only way I can see that prosperity and peace will come to earth. It's not through singing John Lennon's song, "Imagine all the people living in peace." That's utopia. It's shock therapy. Once you realize there is another population out there, and we should all work together to survive just like they did, or we have competition with them, or they pose a threat to us, or whatever, it will bring people together. And there is this notion in religion of a Messiah. And it's usually thought to be someone who lived on earth, a passenger on this boat that we all occupy. What I'm saying is that it may be someone from another star that will bring peace and prosperity to earth. And that's a huge impact on world politics, a huge impact on our aspirations for the future and the way we behave towards each other. What else? How can science bring a bigger impact than that? So now, the argument is similar to Blaise Pascal, who said, he was a mathematician, and he said, well, there are two possibilities. Either God exists or does not exist. That's what Pascal said. And he said, well, you can be an atheist and say that God doesn't exist. But if you just imagine the implications, if God exists, then you can't ignore that possibility. You cannot just say, brush it aside, because if God exists and you made a mistake, the implications would be huge for yourself. And so I just use this argument in the context of another civilization.
Yeah, it's very much an optimistic and an uplifting view of things. I'm curious about, as you said, we've had modern science for on the order of 100 years, which is essentially zero in the context of the scale of the universe. And if we were to encounter an advanced civilization, almost certainly they would be orders of magnitude more advanced. It would be very, very unlikely for that not to be true. But that also means that, well, firstly, I think we would probably be largely irrelevant to them from an intellectual perspective. But secondly, we have very little ability to predict what they might be like and whether they might be, whether we might even feature in their cognition, whether they might be hostile towards us. What is your view on the case for, I guess, optimism for how they would be towards us?
Billions of years ago, okay, we didn't exist. And if they arrive to the solar system, it would be for a completely different reason. And once again, it's this notion that we are important and significant, and if they come here, it's because of us. And when you see a single person who keeps saying, where is everybody, the way Enrico Fermi said, and not without doing anything, because Fermi didn't build a telescope to search for them. You just tell that single person that it's very pretentious to imagine that you're so attractive that everyone will come to you when you want it. And in fact, it would be much better for your life if you wanted to find a partner, to leave your home and go to dating sites, or at the very least look through your windows and search for neighbors. And that's the way I think about it, that we really need to put the effort first before coming to any conclusion or having any opinion on the matter. And people might say, oh, well, we try to listen for radio waves, but that's, once again, like waiting at home for a phone call. It's a very specific approach that is not always giving results, because nobody may call you when you're waiting. And you need to be proactive, look for objects, for example, that represent others. Altogether, I think there is an opportunity for us to do much better, because now we have instruments, we have the ability to process huge amounts of data with artificial intelligence. I should say that yesterday I was contacted by the CEO of, or the founder of a new AI company called Cicero. And he told me that they produced a replica of me, an AI avatar that was trained on all the interviews that I gave, all the essays that I wrote, the books that I wrote, everything out there. There is a lot of material. And I was very pleased because, in when artificial intelligence was developed, the latest models of large language models, I was happy because it would save me time in planning trips, in filling up forms, and managing my time and so forth. But then I realized that there are too many requests for interviews on podcasts um, and for newspapers and so forth. And if I had an AI avatar that is trained on my materials, I could just send it to answer the questions in those podcasts and save time, and dedicate that save time to creative work in science. And even though it sounds like a fantasy, I got one step closer yesterday to fulfilling it, because now this company generated an AI avatar of me that is capable of answering, by voice and or text, answering questions in the spirit of the way of my writings and my interviews. And I was very interested to see who else they made replicas of, and the list that they sent me includes 24 people, including Albert Einstein, including Volodymyr Zelensky, Kamala Harris, Joe Biden, Putin, Trump, and Sigmund Freud, and John Kennedy, a lot of very important people. And I was surprised that they included my name there as well. But at any event, I sent an email to my research group and said, please interact with this system, with this AI avatar, and tell me if you see any red flags. And in response, I got a very positive answer from the people who interacted with this AI avatar. And the reason it touches a nerve for me is because both my parents passed away more than 5 years ago. And I only wish that Cicero, this company, existed back then, because if there was a replica of them, I could still inform that the neural network system of the latest developments in my life, and could have obtained the most likely answers that they would have given under these new circumstances. And right now, large language models have a number of parameters that are about 500 times smaller than the number of synapses in the human brain. We have about a quadrillion synapses. These are connections between neurons in the human brain. And the best large language models have about 0.2% of that. So no wonder that you see the current LLMs hallucinating, making trivial mistakes, inventing references, not really standing up to the quality of the human brain in some tasks. Not in all. In some, they are doing very well. But on the other hand, if you think about Moore's law, the exponential growth in the computational capabilities of chips of given size, within 10 to 20 years, it's very likely that the AI systems will reach the number of parameters as the human brain has. And at that point, it will be as complex as the human brain. For example, the fruit fly has thousands of neurons, and they were all mapped. And therefore, we can create a computer model of the way that the fruit fly thinks. But we tend to think that as humans, we have free will, meaning that I can decide whatever I want. But the only reason the human brain is not predictable is because it's very complex. It has so many connections, and in systems that have a lot of degrees of freedom, you get chaos, you get quantum uncertainty playing a role. So, and the human brain interacts with an environment that is not fully known, that has a lot of free parameters as well. And so when you put the human brain in an unpredictable environment, you end up with unpredictable decisions that you might call free will, but it's still a it's something that we can create with an AI system. That's my point. And so when AI reaches that point, I would like to have my personal Turing test of letting my AI avatar interact with people like yourself in interviews, and you will decide if it's any different than interacting with me. And if you agree that it's not very different, that will save me a lot of time.
Yeah, well, I'm convinced that in this present case, I'm still interacting with you, but it does open up a question as we bring to a wrap. Suppose we were to send an AI avatar out into space to meet an advanced civilization. Suppose we knew where they were. And the best way, obviously, we wouldn't send a biological being; they would probably disintegrate on the way. But so we sent an AI avatar. Which person, past or present, do you think we should send to represent us to this technological species?
It's in the same spirit as my biological daughters. Sometimes I don't fully understand them, but my hope is that they will be better than me. And the same is true about my students. I hope that they will do better than the current people in academia. And I don't care if it's a technological neural network system like large language models or neuromorphic AI. It doesn't matter to me if it's a piece of technology or it's biological. I really hope the future is better than the past. And for me, if we send out something that is the most accomplished neural network system, even if it's not biological and doesn't represent any person, any human on Earth, I would be proud of it.
Avi, you've written prolifically, you've spoken prolifically, you've produced so many good things in the world. If people do want to follow up and find more of what you're doing, where's the best place for them to go? What should they do?
If they want to follow updates on my current research, you can subscribe for free to my essays, Avi Loeb at medium.com. Otherwise, there are two popular level books that I published over the past couple of years. One is Extraterrestrial, and the other one is Interstellar. And I'm now working actually on two new books related to the expedition to the Pacific Ocean, one for adults and the other for young adults, kids, because I want to inspire them to get into science. And finally, by the end of 2025, there will be a Netflix documentary about my research. They went with me to the Pacific Ocean, and it should be very exciting to see the film and just stay tuned for that.
Oh, fantastic. Yeah, I'm looking forward to that one. Avi, before we wrap, anything else that you would like to share? Any calls to action for the audience? Anyone who's been listening and wants to understand more, follow up more? Any final words?
Yeah, if anyone wants to be, for example, a contributor to the Galileo project, if the level of donation is high, please contact me, and you could potentially be part of the next expedition to the Pacific Ocean. We are now collecting people who might want to support that expedition. The cost would be $6.5 million, and we hope to split it among 6 to 10 people. And we have some interested already. But at a lower level, even a small donation could help a lot, the Galileo project. And I'm basically, I was born on a farm, and I think like a kid. I have a beginner's mind, and I enjoy working with young people because they don't, they are not attached to their ego, and they are not, they haven't built echo chambers that amplify their voice. They are more curious and open-minded than the adults in the room. And so if you're interested in pursuing science, I hope to see you in the scientific community and potentially collaborate with you, because it's supposed to be fun. We are supposed to be driven by curiosity. And so the more of us who are curious, and I have a number of postdoctoral fellows and students that came to me and said that it was their lifelong dream to work on the subjects that I'm working on. So I feel young as a result of working with them.
Beautiful. Avi, it's been a great conversation. Thank you for your work, and thank you for joining me today.
Thanks for having me.